Let's get started on using simple transformers. So in this video I'll explain the difference between the transformers architecture and the libraries named transformers and simple transformers. There'll also be some tips for getting started, and then I'll show some code examples for classification, regression, and language generation. I'll explain what those are in a bit as well. So transformer is a type of architecture that is used by BERT and other modern language models such as GPT-2, Roberta. There's a paper called Attention is All You Need that you can look up some explanations on YouTube. But from a coding example, from a coding perspective, in this video we're talking about the Python library called Transformers, which comes from Hugging Face. And the models that are available on the Hugging Face site can all be loaded through this. They're generally compatible with both PyTorch and TensorFlow architectures. And the Transformers library also is compatible with their tokenizers library, which helps you get this large block of text divided up into word and subword pieces. Simple Transformers is a library that helped me get started in NLP by a huge, just being so much more accessible to use and frame problems. So the website simpletransformers.ai has some documentation. It's based on the Transformers library. Because of how it was designed originally, it is only PyTorch and GPU compatible. There's not really the TPU support, but it's a lot more accessible, and I think when I show you the code, you'll agree that it makes sense. Some things that I'll point out is that PyTorch, transformers, and simple transformers are all made by different groups of people. So sometimes you'll run a notebook that ran perfectly fine before, and you'll get kind of a weird issue. So my recommendation, having run a lot of projects with this, is to go to the PyPy site. That's the same site that pip uses to install the library, and see if there was a recent release. If there's been an update in the last few days, maybe you need to install an older version, maybe you need to update your existing version of code for compatibility. If you find the problem is just recently introduced, report the new bug on the Simple Transformers repo, and they generally have a good response time on that. Our transformers, yeah, so if there's an issue where deeper down transformers, tokenizers, TQDM are not compatible with your current version, see if there's a message in the debugging thing telling you to install a different version. Maybe downgrade from the most recent update to transformers. Restart your instance once everything's installed. Just hack around with it, and generally you can get everything to sync up with each other. Let's show some example code. So here, pip install simple transformers. If you're not familiar with the Google Colab or notebook system, usually you write Python here, but writing an exclamation point in the beginning means I'm writing this to bash, and it's going to do a pip install. So once that's all loaded up, I copy the CSV files from my Google Drive, and we get a little preview of the first one. So here we have the here we have the news description, kind of the headline. Then we have the English name for the category and the Tamil name for the category. So there's 6 different categories of news in this data set. The first one here is in the world news, and the second one is cinema, movie news. In all, it turns out there's 6 different categories in this data set, but I'll explain how I know that later. So the way that I get from this raw CSV file into a pandas data frame that I can use with simple transformers is I import pandas, read in the CSV, I filter down the columns to just get the ones that I want. The first column should be the text, and the second column should be the category. Don't include any other columns in this data frame. Next, right now the category that we saw already is just a word representing the category. we need to turn that into a number starting at 0. So here on this line, I convert it into a categorical type, and then I set the categorical type to its code number. Next, I use the dropNA function to drop any empty rows, and we see a preview here of what we're looking at. In this case, the test dataset is provided as a separate CSV, so I'm going to keep that same train and test split. I follow the exact same process to pull out the headline, text, and category number values, drop empty rows, and here's the test value. Here I can see that the number of unique values for a category is 6. So what do we mean by a classification task? As you've seen, this is dividing up headlines into 6 specific categories or labels. And so classification is sort of a labeling task. Here we have only one label. There are other systems where you can have multiple labels on the same data set or same piece of text, but there are different ways you can load that also with SimpleTransformers, but this is a more cut and dried example of everything should be labeled in a particular way. So here we show how to run a classification task. I import classification model from SimpleTransformers, then I select the model from Hugging Face repo that I want to use, and then here I've passed the architecture that I want to use, BERT in this case. There's also models there that use more Roberta or Distilbert kind of models. Here's what else I'm passing. The number of labels, which we know is 6. I set CUDA to true. That's the library that communicates with the GPU. Then I passed in these arguments because I found that's the best way to always reprocess the input data if I've made any changes upstream of this. Train for 3 epochs. And then silent true is something I do to avoid printing out a bunch of progress bars. You can always comment this out if you want to see what's going on as it's happening. Then I pass the train data frame to train model. Now that it's trained, I want to know if it actually works or how well it works. So I pass the test data frame to evaluate model or eval model. Here I have my own system of tallying up the incorrect answers by label, and I found out that I have 74.1% accuracy at sorting into these 6 different news categories. The next thing I want to know is how does this compare to other models that are around. So at the time, the only other model that I knew that could support Tamil language was multilingual BERT. So this is another model that's hosted by Hugging Face. I did the exact same code, same amount of training, same exact test code, and here we can see it only had 53.2% accuracy. More recently, Google released a model called Mural. Here I've commented out the silent parameter so we can see how it did the training, track this progress. Took about 10-12 minutes to run everything all together, and that has an accuracy of 81.3%. So this is currently the best model I know for doing classification with Tamil. The next one that I'll show you is a regression task. So regression, instead of assigning a label to some text, we want to assign a number. So a good example would be if you had some descriptions for products or houses or hotels, and you wanted to estimate the price. And so, when we were doing classification, the difference between saying something's a cinema story or a sports story is they're completely 2 separate different things. Whereas if we're talking about housing prices, if I say something is 10,000, 11,000, 12,000, you can say, 11,000, 12,000 are closer. You can measure the difference between these different categories by they're all on a number line somewhere. So for regression, in this case, I had star reviews from Amazon. And this is a little tricky because I think people say, oh, there's 5 different options: 1 star, 2 star, 3 star, 4 star, 5 star. And so that's a classification problem. But again, think about this more carefully. The difference between, not knowing the difference between 1 star and 2 stars is very different from not knowing the difference between a 1 star and 5-star review. So we want to plot these numbers on a number line, and even if we're not sure if it's 1 star or 2 stars, saying 1.5 is a useful piece of information. So there's not a different model name in SimpleTransformers. We still import the classification model. We do 2 different things. One is we set num labels equals 1 here. The other is we put regression true over here. Great. So I passed the training data they've collected. This took a lot longer to run, altogether about hour 45 minutes it says, because I was running this on a much larger data set. And here, instead of a percent accuracy, I use the square root of the mean squared error. That means that if this number is lower, then that's better. Here we see that Multilingual BERT had a, when I ran the, when I did the same measurement, was a little bit higher there. So, long story short, for regression tasks, just look up how to do it. You do 1 label and regression true, and the 2 columns should be the text, and then the second column being the numerical value. The final one I'll show is language generation. This is, when we talk about GPT-2 or GPT-3, or I gave an AI 100 hours of Harry Potter and it generated this or something like that. So this is very simple. You load a model that's capable of language generation, and then you give it some starting text. The example that I have for this that I'm currently working on is if I give it Halloween is October blank, it should say October 31st. It's not always doing that, which is a little interesting to me. But anyway, here you can see how to generate or how to get language generation model out of SimpleTransformers. A lot of people write to me and say, hey, I see you do this stuff with Tamil and Spanish or Hindi or another language. Let's get going. Let's start generating text. But these architectures are totally different. GPT-2 is very English-centric, and it's designed to generate text, whereas BERT-based models, like I was using in the previous examples, are designed to fill in words in the middle of the sentence, or just like one word at a time, and they can be used for classification and various tasks, but they generally can't be used for language generation. Even if you did, it would just generate 1 or 2 words at a time. Whereas when you're doing GPT-2 to write a story, you want it to generate dozens, hundreds of words. So there are a limited number of models that are good at this. So I'd recommend, if you're interested in language generation, coming up with new sentences and stories, you might want to start training from scratch, or there's some tutorials out there where you take the existing English GPT-2 and you turn it into another language model. The example that I saw being a Portuguese example. So let's go back. So we've covered classification is labeling some text. Regression is going from text to a numerical value as close as possible on the number line. And language generation is you feed in some initial writing prompt, and then it continues writing. In the next video, I'll be showing a little bit more about different learning styles you can use when you're getting started with machine learning and natural language processing.